friends, today we are here with the chapter Periodic Classification of Elements, and this is the classification of elements which was proposed by Dobereiner in 1817. So let us first know what are elements. An element is a pure substance made from only one kind of atom. An element is a pure substance made up of only one kind of atom. This is a point to be noted, that only one kind of atom means, here I will give you a simple example of hydrogen. As you all know that hydrogen is the first element in the periodic table and it is having an atomic mass of 1. It is having 1 proton and it does not have any neutron in its nucleus. This is a very important thing to be noted, that hydrogen is the only element which does not have a neutron in its nucleus. It is, again I repeat, hydrogen is the only element which does not have any neutron in its nucleus. Now, this is the Dobereiner's law of triads, and these are the examples. These first 4, these are the Dobereiner's law of triads, and this last one, we will see what is about this last one. It is written in different color. So let us see it afterwards while explaining. So first let us read this law. When elements having similar properties are arranged in increasing order of their atomic mass in groups of 3 called triads, the atomic mass of the middle element was approximately equal to the mean or average atomic mass of the other 2 elements. So this is the law. I think that you have written this law. Now let us take each and every point here. When elements having similar properties. Now let us consider this triad, lithium, sodium and potassium. All these are alkali metals, calcium, strontium, barium. These are alkaline earth metals, chlorine, bromine, iodine are halogens, sulfur, selenium, tellurium. These are the non-metals, and nitrogen, phosphorus and arsenic. These are the nitrogen group elements. Now before Dobereiner, the classification was metals, non-metals and metalloids. So which are the metals here? So all these are metals, okay. These are metals. These are non-metals. All these you can see here, this one, that is iodine, bromine, chlorine, sulfur, selenium, nitrogen and phosphorus. These are non-metals. And arsenic and tellurium, these are the metalloids. This point should be noted. Now you can see here increasing order of atomic mass. Let us read the atomic masses: 7, 23, 39, 40, 88, 137, 35, 81, 126, 32, 79, 127, 14, 31, 74. Have you followed that? While reading, you have followed that these are the atomic mass which are arranged in increasing order. This point should be noted, that you read this atomic mass loudly and you will come to know that they are in increasing order. Now the very last and the important point, that is the atomic mass of the middle element was approximately equal to the mean or the average. So let us see what is the mean or the average. You pause this video and write down this law. Now, let us see here that we have actual atomic mass of sodium 23 and actual atomic mass of strontium, that is 87. Now, we have to calculate the mass of sodium and strontium. And we have to clear this point, that is the third point. The actual atomic mass of the middle element was approximately equal to the mean or average of the atomic mass of the other 2 elements. Let us see. Actual atomic mass of the middle element is equal to, approximately it is equal to the atomic mass, average atomic mass of the first element and the third element. Again see, atomic mass of the middle element, it is equal to the atomic mass of the average atomic mass of the first element and the third element. Let us verify this law for this first triad. Now atomic mass of lithium, it is 7 plus potassium, it is 39. So divided by 2, then it is coming out to be 46 divided by 2. So what is 46 divided by 2? It is 23. So you can see here that the law is verified. See, this is coming out to be equal, and therefore the law is verified. Okay, followed it. Now the second example where you have taken here that 40 plus 137, then 40, okay, then what is here 137, let us write 137, you also write in your own notebook, divided by 2. Then what is it coming out to be? It is coming out to be, I think that it is 177 divided by 2. So it is coming out to be 88. Okay, is everyone getting it? 88? Everyone should get it, 88. So 88 and 87.6, these are approximately equal. Then what about this nitrogen, phosphorus and arsenic? Let us calculate. You can calculate it roughly by yourself just by observation. This 14, let us write it. 14 plus 74, how much it is coming out to be? It is 88. How much it is? 88. And then average divided by 2, it is coming out to be 44. Okay. So this is the average atomic, calculated average atomic mass for phosphorus. But actually it is observed that actual mass is not 44 for phosphorus. It is not 44. How much it is? Actual atomic mass? It is 31. So actual atomic mass 31. It is not matching with the 44. It is not at all matching with 44, and therefore this last one, it is not a Dobereiner triad. So Dobereiner was able to classify only 4 triads in the periodic from the periodic table, and therefore this law has its own limitations, and therefore we will have to study the next law, which is the Newlands Law of Octaves. Now before studying the Newlands Law of Octaves, let us see that what about this, let us see this point once again. Element was actual atomic mass of the middle element was approximately equal to the mean or the average atomic mass of the other 2 elements. Actual atomic mass of the middle element is equal to the average atomic mass of the other 2 elements. Followed. Average atomic mass of the middle element is equal to the average atomic mass of the other 2 elements. And now what you have to do is that you have to solve the question answers from Can You Recall. This is for your homework. You have to write these notes by yourself. You have to keep your notebook very neat and tidy so that we can check your notebooks whenever you come to school after the lockdown period is over. So all these things should be followed, and regularity in your studies, you should follow all these things particularly. Okay, and any of the difficulties we will be solving it after we complete the whole of our chapter. Okay.